Good morning, class 12. We are back with another topic. And yesterday we have done the chemical properties of the formaldehyde. And I accept it was a lot of work for yesterday. It was the longest class, it exceeded 1 hour time. Excuse me. But we had to do that class in one day because we could not leave some properties of formaldehyde for them later. So I had to finish that. I hope you have understood the chemical properties, reactions, tests for formaldehyde. And I'm also sure that you have checked in the description the links to the other videos where you could have seen the tests, the laboratory tests. I'm sorry I couldn't check the feedback from you, but I will check today anyway. And I will first answer a few questions from the yesterday's lecture. I didn't see all the homeworks, but few homeworks that I came through, and there was one question asked by Alishba Zafar, where she was asking about trimer. Like, what is a trimer? Tri means 3, mer means unit. So if any compound is produced by 3 molecules of similar kind, it is called a trimer. So metaformaldehyde is a trimer of formaldehyde. So it is produced when 3 molecules, 3 units of formaldehyde combine. If I have some space on the back, this is first year's, I will again try to show you. Now this is 1 molecule of formaldehyde, okay? 1 unit. This is the, carbon. This is the other unit. And this is the other unit of formaldehyde. So how many units, how many mers are these? 3 units, okay? This pi bond comes over here, this pi bond goes there, this pi bond goes there. So when 3 units combine, you get carbon, single bond oxygen, single bond carbon, single bond oxygen, single bond carbon, single bond oxygen, single bond carbon. Every carbon has 2 hydrogens. So CH2, CH2, C. This product is called metaformaldehyde. Now it is a trimer, because tri means 3 and mer means units. This metaformaldehyde is also called trioxane or trioxin. Trioxane or trioxin or 1,3,5 trioxin. 1, 3, 5 trioxin. Now this is the same, it's the metaformaldehyde. So trimer means a compound which is formed by the combination of 3 units. Now you should also remember in the manufacture of benzene, 1 benzene molecule is formed from 3 acetylene molecules in the preparation of benzene. If you remember, it's the 4th preparation of benzene in the 7th chapter. This way, benzene is a trimer of acetylene, just as trioxane is a trimer of formaldehyde. So this question came across, I just wanted to explain. And now we go to our lecture. Today's lecture is about chemistry of acetone. This is acetone, right? Similar structures. Acetone, I just pre-wrote all this so that my lecture is to the point and I'm not going all over the place, not wasting your time. Acetone is the first member of the ketone family. As we all know, it is the first ketone. Propanone, the common name is dimethyl ketone, 2-methyl to a ketone carbonyl group. IUPAC calls it 2-propanone or propane 2,1. If you want a capital P, you can go propane 2,1. Otherwise, 2-propanone will also work. And acetone is naturally found in wood spirit. If you know wood, yes, when we burn wood, previously energy was found by burning wood. Even these days in villages, there's no natural gas, so the people of the village they burn wood. When wood is burned, a dark brown liquid is produced from the wood, which contain methyl alcohol. You know, the number one ingredient of wood spirit is methyl alcohol, but it also contains acetone. So this is a natural source of acetone. Acetone is found in our blood and urine. Basically, it is the product of metabolism when our gastrointestinal system metabolizes the food we take. The aldehydes, the glucose, they are burned as fuel. However, the ketones, they are excreted through urine. So a normal amount of acetone in urine or blood is okay. But if you have excess amount of acetone, that shows that you are suffering from diabetic mellitus. Diabetic mellitus is a disease when our cells cannot consume the energy that we take or consume glucose due to the insulin resistance problem, or cells become insulin resistant. So that is the thing, okay? So there are two types of this, type 1, type 2. In type 1, our pancreas don't make, I'm not sure, and I shouldn't talk about things that I don't know, but I just wanted to give you an explanation. So an excess amount of acetone in urine will indicate the disease called diabetes, or also called diabetic mellitus. So preparation, how we prepare acetone. Now, guys, secondary propyl alcohol, if you use primary propyl alcohol, it'll give you aldehyde. I'll do that as well. See that you have CH3, CH2, CH2, OH. Now this is a primary alcohol. If we oxidize the primary alcohol, please don't write this in your copy because this is to give you the introduction. These are the oxidizing couple. This first carbon is oxidized. So you have CH3, CH2, and CHO, or C double bond OH. This is primary propyl alcohol, and this is propanol, the aldehyde. So every primary alcohol, when it is oxidized, it gives you aldehyde. But if you use a secondary alcohol, my friend, then secondary alcohol, the OH group is bonded to a carbon other than first carbon. So it is in the middle. So once you oxidize the secondary alcohol, you are very strongly, you're going to get the carbonyl group in the middle somewhere. So let me show you the secondary alcohol, okay? CH3, all right? And then CH, and then OH on the top. I'll make OH here. And let's say CH3 here. Now, this is secondary propyl alcohol, also called 2-propanol, 2-propanol. Sorry. Now, if you oxidize this, adding oxygen, which comes from the most trusted oxidizing couple, sulfuric acid concentrated and the potassium dichromate. Now, here I want to point out this hydrogen and this hydrogen, they bond with oxygen to form H2O. Now just think yourself, if these two H are gone, then this p orbital of oxygen and this carbon's orbital, they overlap, make a pi bond here. So these will make a pi bond here, and you will see CH3, C double bond O, and then CH3. You can make double bond up and CH3 straight forward. This is called acetone or 2-propanol or propane 2,1. Since we are writing the preparation of acetone, we mean to write this in a fair copy, but just to give you the introduction, the primary alcohols are always oxidized to aldehydes, and secondary alcohols are oxidized to ketones, and tertiary alcohols are not oxidized because there's no hydrogen. Remember, you need alpha hydrogen, a hydrogen attached to alpha carbon. So tertiary alcohols don't have alpha hydrogen. I can make it for you here. CH3, C, CH3. Now this is a tertiary alcohol. Now to remove two hydrogen, this carbon doesn't have a hydrogen. So removing a electron donating alkyl group is difficult. So primary alcohols, aldehydes, secondary alcohols, ketones, and tertiary alcohols not oxidized. All right, is it clear? This is the method to prepare the acetone. The next method is by heating strongly acetic acid. Now, acetic acid is found in vinegar. It is also a natural product. So when you heat it as high as 500 degrees C, this is organic chemistry. So this is a very high temperature. So heating something at a high temperature in absence of air or catalyst is known as distillation. Destructive distillation is also called cracking, and it's also called pyrolysis. So pyrolysis, so what's going to happen, the two molecules of acetic acid, also called ethanoic acid, because of two carbon, will break and then recombine into, you can see that, CH3, C double bond O, and CH3. One carbon will make carbon dioxide gas and then steam. So acetic acid can convert to acetone. These all preparations also are found in a convert reaction. As I told you in the annual paper, there is a convert question. So they are found there as well. So this is very simple. Pyrolysis of acetic acid into the acetone. The third method, I pre-wrote few things, few headings, so that our lecture is to the point. Teachers normally get carried away with the topic. So calcium acetate, this is from yesterday, from a day before yesterday. Calcium formate, formaldehyde, calcium acetate gives you acetone. So CH3, C double bond O, and O, that's acetate ion. CH3, C double bond O, and O, this is called acetate ion. Calcium bonded to acetate ion. So dry distillation, heating in absence of air. Also pyrolysis, you can say that. As you know, and you have done as well in the previous lecture, CaCO CH3. So what is left? CH3, C double bond O, and then CH3. This is the dry distillation product. This is calcium acetate. I will write here. Cal for calcium, acetate. This is acetone. I want to do it again like Ca, CH3, COO2. This is also a formula of calcium acetate. So then the similar product, you can say that CH3, CO, CH3. Just an alternative reaction. So the three simple method of preparation for acetone. Mostly you have done some of them already. Let's jump to the physical properties. It's colorless, transparent liquid, inflammable, can catch fire quickly. All right. It has a peculiar smell. It means it has a characteristic smell. The smell belongs to it, is just its smell, and you can just identify immediately that this is acetone. And if you are girls and you are definitely if you are girls, you are a girl, you are familiar with the nail polishes and nail polishes. Even some guys are also, it depends on what type of, okay. So nail polish removers, if you smell it, that's pure acetone. So anywhere, if you smell that thing, you will say, oh yeah, it's acetone. So it has a particular characteristic smell from which we can always easily identify acetone. It dissolves very nicely in water, ether, alcohol. Even itself, it is also a solvent. Very low boiling point, 56.5 degrees C. That's why it is very much volatile. If you guys know volatile, what happens if you leave the bottle of nail polish remover open? It's gonna disappear in few minutes. So this is volatility. And it has a specific gravity of 0.792. It means that the volume, if you take water and acetone of same volume, what will be heavier? It will be lighter. Okay? So what do we mean by specific gravity? Technically, it is density, but it is actually compared with the water. So it tells it's very thin liquid. All right. In chemical properties, there are very few because it's a solvent. You can convert acetone back to acetic acid. All right. Back to secondary propyl alcohol from which it was made. So if you reduce either hydrogen, pi bond will break. CH3, C double bond O, CH3. You all know one bond is sigma, one bond is pi. So when you add hydrogen, you can use nascent hydrogen. If you don't want to use nascent hydrogen, then you need palladium or platinum or nickel, and you warm it so the molecular hydrogen converts into atomic hydrogen, and this will attack on the pi bond. Sorry, pi bond is here, so attack on the pi bond. So when pi bond opens, it makes two sigma bonds. So one H will bond to the oxygen, CH3 will remain as it is, C, and one H will come here, and one H will bond to the O, so it will be OH. So my friends, if this is acetone, 2-propanol, what is this? Secondary propyl alcohol. Secondary propyl alcohol, isopropyl alcohol, 2-propanol, whatever you want to call it. This is propane 2,1. This is propane 2-ol. So simple, okay? You can make it like this. and then you can make a double bond oxygen. This is propane to 1, and when it adds hydrogen, it doesn't happen without a catalyst. This is called catalytic reduction. Such reduction is called catalytic reduction. I have taught you plenty of times difference between the catalytic reduction and nascent hydrogen reduction. So this one is slow, that one is quick, this one is cheap, that one is expensive, and this will be like this, but they will be OH. So this is propane to 1, this is propane to O. 2 propanol, 2 propanol. Clear? So it's 2-propyl alcohol can give you 2-propanol, and this is just a reverse reaction. Next is oxidation, and when you oxidize it, you add oxygen. So this one, in this one, it will form the acetic acid back from the acetone. So when acetone is oxidized, you guys know oxidation with oxygen, and from where the oxygen comes, huh? What is the most famous oxidizing agent? Couple potassium dichromate and sulfuric acid concentrated. Now, when it adds oxygen, it basically forms acetic acid. This is a method of preparation of acetic acid you will learn in the next topic. How you make acetic acid from acetone. Acetone is oxidized to acetic acid. Okay. Ethanoic acid. And this is CO2 and H2O. This is a copy of this reaction, the preparation one. Acetic acid, strongly heating, acetone, acetone oxidizing acetic acid. All right. Now, how can we test in the laboratory that acetone is present? The qualitative determination of acetone. As I told you, and if you have seen the lecture of yesterday, and if you go into the description, there will be written, I gave you a few tests, lab tests. So how can you determine the presence of this acetone? You need iodine, a mixture of iodine and sodium carbonate. And you will, if you see yellow precipitates, a yellow coloration, that indicates the presence of acetone. So when acetone, CH3, C double bond O and CH3 reacts with the iodine, it will not react unless the iodine is mixed with sodium carbonate. So acetone is heated with a mixture of iodine and sodium carbonate. Immediately you would see very strong yellow color PPTs, CHI3. This is called iodoform. If you know CHCl3 chloroform, right? So this is CHI3, so iodoform. Iodoform will form along with the sodium acetate, salt, and of course sodium. There are 2 sodiums, so in fact there are more sodium, so 3 NaI plus 2 CO2 plus H2O. This way acetone, if you think that any beaker or any test tube contains acetone, you drop these 2, warm it a little. If the yellow coloration appears, you will say positive for iodoform test. In the laboratory, when we do qualitative determination, what's qualitative to find whether this thing is present or not, we use it. Okay, simple reactions, very easy. We jump towards the uses. Acetylene, you know, ethane gas catches fire used in welding, a very dangerous gas, but it is soluble in acetone, and acetone works as a carrier of acetylene can carry it from one point to other point. Acetone can dissolve plastics. Nail polish is also plastic, enamel, so it can dissolve it. In the same way, you can remove plastic paint from anywhere up using acetone. If you have sometime, if you remember in the classroom, maybe with me, I have done it a lot of time. When you use a permanent marker on a whiteboard and it doesn't erase the an eraser, what we use, we apply acetone and remove it. I have not used acetone. I have in a lab but I have used petrol from anybody's bike. That's also a solvent. So the cellulose nitrite, cellulose acetate, celluloids, all these plant products, cotton makes fabric. So how does cotton make fabric? First, cotton dissolves in acetone and make a collidone mixture, and then you make the fibers from it and then process. So industrially, acetone is the number one solvent when it comes to uses. Okay, and it can also prepare iodoform and chloroform in the preparation. Use as, of course, nail polish remover, but also in perfumes, in scents. If you want to make a perfume of rose, so how can you make it? You have to put rose petal into something which can dissolve rose petals. Water can dissolve rose, but very little. Acetone can dissolve it very easily. So if you have a flower in your garden and you like the smell of it, take it, dissolve it in acetone, and that's your scent is ready. So that's how they make. They used to make scent in the early times. So all perfumes, deodorants contain acetone, and this acetone is also used to remove the makeup. Makeup in the movies, makeup artists. Lots of work is done on the face. If you know the movie Joker, Jacqueline Phoenix, all this makeup is so sticky and doesn't come away. So acetone is used to clean it. So cleansing agents have acetone. And in the movies, somebody apply the mustaches or a wig or something fake skin like this. There's a lot of hard work done after the shot when they use acetone, and the whole artist's face is like washed with acetone to remove all that stuff, because acetone dissolves. It's a number one solvent. The country which makes the most of acetone in the worldwide is USA. 17% of acetone around the world comes from USA, and the company of USA which makes it is Shell. Shell, the petroleum company, they make it. Second is China. All right, so acetone is used in the industries, and it can be used to make rubber and many plastics. Methacrylate plastic is made from acetone, and that's all about the chemistry of acetone. Now, my dear friends, as we have completed the aldehydes and ketones, and we have completed the chemistry of formaldehyde and acetone. So our test will be on Sunday evening. Written test, basically, sorry. So topics are preparation, properties, and uses of formaldehyde, and same of acetone. Not naming, but the preparation, properties, and uses. You can do this on Sunday evening from 5 p.m. to 7 p.m. in between this time, in the supervision of your parents. We don't want to disturb them, but just as we trust you, but just as so this is how we should do. Tomorrow is an important lecture, and I will be teaching you tomorrow naming of carboxylic acids. How can we name IUPAC naming of carboxylic acids, and maybe the preparation properties of acetic acid. So we are going to finish this chapter very soon, and not just we will finish it, but we'll also remember it for our examinations. I hope this will work for us. Thank you so much for today's lecture, and that's it from my side. Stay safe, stay home, and work. Bye.